Let's start section 3.6. 3.6 is about polynomial and rational inequalities. Let's talk first about the definition. Which kind of polynomial, or what is polynomial and rational inequalities? Any polynomial or rational function that's in the form of f of x greater than 0, f of x less than 0, or f of x greater equal 0, or f of x less than equal 0, we call it a polynomial inequality. Correct? To give you numeric examples, for example, if I have x squared plus 5x plus 6 greater than 0, my left side is a polynomial, and I'm using one of these signs: greater, equal, greater, less than equal. I call these ones polynomial inequality. Or here another one, let's say x squared less than equal 9, or maybe x squared minus 7x greater equal, let's say, negative 10. Correct? These type of polynomial, we call them polynomial inequalities. The only thing that we do, we change our equal sign to an inequality sign, which is greater, less than, greater, equal, and less than equal. We have these four options, right? A polynomial can be greater, less than, greater, equal, or less than equal. We just change our equal sign to this sign. Now, how to solve a polynomial or rational inequality? I'll give you some steps. Or in your book, they're calling it procedure for solving polynomial inequalities. Correct? I call it simply steps. How to start, how to solve a polynomial inequality. Step number 1. In step number 1, express the inequality in the form of one of these four: f of x greater than 0, f of x less than 0, f of x greater equal 0, f of x less than equal 0. What does it mean to express in this form? It means if an inequality is given in this form, for example, x squared plus 5x greater than negative 6, what you do, you bring everything to one side and make the other side always 0. That's your step 1. Remember, bring everything to one side and make the other side what? 0. What I'll do, I'll add 6 to both sides to make one side 0. That's my step 1. Then I can write x squared plus 5x plus 6 greater than what? Greater than 0. That's my step 1. If your inequality is given in the form that you have numbers on both sides of inequality, bring everything to one side and make your right side always 0. That's your step number 1. Step number 2. In step number 2, write your inequality in this form: f of x equals 0. Instead of greater, less than, greater equal, less than equal, we back change it to equal sign. Correct? It means if I talk about this example, this one, x squared plus 5x plus 6 greater than 0, in step 2, I will rewrite this as a x squared plus 5x plus 6 equal 0. That's my step 2. I'll change the inequality sign to equal sign. Step number 3. After you change it to the equal sign, solve the inequality. Correct? Actually, in your book, in step 2, they said, oh, make it equal to 0 and solve. I made another step. Okay, now after you made it equal to 0, now solve it. And you know, some of them is quadratic, maybe some of them becomes third degree, some of them, of course, they are not linear. Even linear comes under the polynomial inequalities, but in this section they cover more quadratic for you. Now, how to solve a quadratic equation? It means in step 3, always what? Solve. How to solve? Here I have x squared plus 5x plus 6 equals 0. If I can factor, I'll use the factoring method. If you cannot factor, or you don't remember how to factor, use the formula. X, if it's quadratic, x equals negative b plus minus square root of b squared minus 4ac over 2a. You can use your quadratic formula, correct? But if you can factor, the easy way is factoring, correct? Here, for example, x and x, two numbers to multiply gives you positive 6, to add gives you 5. Of course, they're x plus 2 and x plus 3. Then x plus 2 equals 0. From here you can say x is equal negative 2. X plus 3 equals 0. From here you can say x is equal negative 3. The solution for this equation, we call it inequalities. They are the boundary points. We call these two boundary. I missed an A. Points. What does it mean? What is boundary points? Boundary points, as you see clearly in this example, are actually the x-intercept of your graph. Let me explain this boundary point, because most of the students, when I had face-to-face classes, said, why we are using, what is this word? What does it mean, boundary points? What are those boundary points? Because I'll show it immediately on the number line what is the boundary point. You shouldn't be confused. What does this boundary point means, right? Look, if I show these 2 points on a graph for you, because I know the shape of this graph, all of us actually, we know what is the shape of this graph. It's a parabola opening upward, correct? Here you have x, here you have y. Negative 1, negative 2, negative 3. Negative 1, negative 2, and negative 3. This parabola has two x-intercepts. One of them is at negative 3, and the other one is at negative what? Negative 2. It means somehow, I don't want to exactly graph this parabola, but I know somehow this parabola crosses the x-axis because we know now, and goes back up like this. Boundary point means your graph has now two parts. The part that is below the x-axis, which I made it green, and the part that's above the x-axis. From where the graph goes below the x-axis, from which point to which point the graph is above the x-axis, we call those points, which is actually our x-intercepts. Let me rewrite here. Your x-intercept is actually your boundary points. We call those points the boundary points. Correct? Now, in this example, I do a lot of explanation. Don't be confused. Draw your number line. You don't need to graph it, right? Don't graph parabola. Just drive a number line. I use this graph to explain for you what is boundary point. What you need, you only need your number line. Mark 2 points here. One of them as a -2 and the other one is -3. X-intercept actually shows your domain from where to where, or how many intervals you have your domain, right? After you show it on the number line, now you know this interval is from -infinity to -2. This interval is -2 to -3. This interval is from -3 to positive infinity. Actually, you have 3 intervals. Look at your graph again. Here, one interval, here another interval, and this side is another interval, correct? You have 3 intervals, correct? Put your numbers on the number line, put your x-intercepts or put your solutions on the number line. Those are your boundaries. Even in the class, I'll tell the students, oh, draw a little bit of line here in your boundaries to know, oh, it's not the exact answer. This is my boundary, correct? Now, step 4. In step 4, pick up a test point from each interval and plug it to your actual inequality, the actual given inequality, and see if that number satisfies the inequality. You pick a number from each interval. For example, in this example, I'll pick a number. Which color I should use? Let me use again black. I'll pick a number here from this interval from -infinity to -2. For example, I'll pick here, oh, I put the numbers here wrong. If it was class, students start shouting on me. -2, -3. Pick a number from this interval, pick a number on this interval, and pick a number. Let me correct my intervals. I didn't focus. I'm dealing with negative numbers. Here -3 to -2, and here -2 to infinity. For example, I'll pick a number here -4, and I'll pick a number between -3 and -2. Maybe what? -2.5. And I'll pick a number between -2 to infinity. Maybe what? 0, the easy one. I picked 3 numbers, -4, -2.5, and 0 as a test numbers. We call it test points, correct? And you use your test points where? You plug it in your inequality. What was the inequality? X squared plus 5x plus 6 what? I used greater than 0? Yeah, greater than 0. You plug these test points where? In your actual given inequality, and you check and you see what's happening when you plug in those test points in this inequality. Is the number satisfies the inequality or not? If you end up with the, on the other language, if you end up with the true statement or false statement, correct? Let's do it. For example, I'll plug negative 4. Here it will be negative 4 squared plus 5 times negative 4 plus 6 greater than 0. Negative 4 squared gives me what? Positive 16. Positive 5 times negative 4 gives me negative 20 plus 6. Is this greater than 0? I'm checking. 16 minus 20 gives you negative 4. Negative 4 plus 6 gives you 2. 2 is greater than 0, right? It means it's a true statement. Correct? Same way, I'll plug negative 2.5 in my inequality, and I'll plug another test point, which is 0, to my inequality. And I see if I end up with the true statement or with a false statement. Correct? Now, in step 5, where is your solution? Your solution for the inequality is the true statement, the interval that satisfies your inequality. That's your solution for the inequality, correct? For example, in this example that I did for you, you had here negative 3, here negative 2, here infinity, here negative infinity. You saw that when I put a negative 4 in my inequality, I end up with true statement. Then x can take all these numbers from where to where? From negative 3 to negative infinity. Why I use parentheses for negative 3? Because still remember, for greater, less than, we use parentheses also for infinity. And for greater, equal, less than, equal, we use bracket, correct? And I know if I plug 0 in my inequality, also I'll end up with true statement. I didn't solve this example as an example because right now I'm just do a lecture for you. I'm just talking, but soon I'll do a lot of examples for you, and I'll solve each point for you. And I see there is another true statement from negative 2 to infinity, correct? Then what is the solution for my inequality? This is the graph, it's the solution, it shows the solution. Or you can write this way. The solution set is from negative infinity to negative 3, parentheses union from where to where? Negative 2 to infinity. That's the solution. The solution set for your inequality, and you are done. Remember, I'll give you a quick, easy method here for graphing, but only it works very well with your polynomial inequalities, not with rational. I want to make your life a little bit easier, but remember, only and only it works very well for polynomial functions, not for rational. For rational, sometimes it doesn't work. If you are dealing with a polynomial function, when you pick up a test point, for example here, which was negative 4, and your statement was true, immediately the next interval becomes false and the next one becomes true. It's like this pattern: false, true, true, false. It's one false, one true, one false, one true. This is the pattern. You can mark it like this. You don't need to plug in a number from each interval to check. But remember, I told you, it works only and only 100% for polynomial functions, not for rational and other types, correct? You can use this method It didn't explain in your book because they know it's not working for other types, but I'm telling you, for polynomial functions, you can use also this easy method. Just plug in one number from one of the intervals and mark it as a true, false, true, false. Correct? That's all the explanation about how to solve a polynomial inequality. Now I'll start with examples for you, and I'll do a few examples for you to show how to deal with polynomial inequalities. Correct? Example number 1. In example number 1, we have 4x squared less than equal 1 minus 2x. I'll do this example again step by step. Step number 1, I'll move everything to one side. It means I will subtract 1 and I'll add 2x to both sides. Subtract 1 and add 2x to both sides. Then I'll end up with 4x squared plus 2x minus 1 if I write all of them in a nice order, less than equal 0. That's my step 1. Step 2, I'll set this equal to 0, right? 4x squared plus 2x minus 1. I'll change the inequality sign to equal sign. Equal to 0. Correct? Step 3, I will solve it. If I can factor, I will factor. If I cannot factor, then what I'll do, I'll just use the quadratic formula. You see, you cannot even factor this polynomial. If you try, there is no such a number to can factor this. Then what I do, I'll use here my quadratic formula. X equals negative b plus minus square root of b squared minus 4ac over 2a. Plug in the numbers. Negative b, it means negative 2, plus minus the square root of 2 squared minus 4 times a is 4 times c negative 1 over 2 times 4. Let's simplify a little bit. Negative 2 plus minus the square root of 2 squared is 4. Negative times negative gives you positive. 4 times 4 gives you 16. Over 2 times 4, 8. Okay, let's use parentheses to avoid confusion. X equals, let's simplify more. Negative 2 plus minus 4 plus 16 gives you 20. And you can write 20 as a 4 times 5, right? And 4 has a square root. The square root of 4 is 2. Then negative 2 plus minus 2, radical 5 over what? Over 8. If you want to simplify more, then you can say x equals, factor out 2. Correct? Then the inside will be negative 1 plus minus radical 5 over 8. 1 time, 4 times. Your two solutions are x equals negative 1 plus minus radical 5 over 4. And if you solve, if you use your calculator, because I don't know, they did this example in your book, which is not a good example as a first example in your book, because even you don't know where are the exact points. If I was writing this book, I would put an exact kind of solution for my first example. Anyway, I'll do another one for you. I'll show you. But if you solve this inequality, you will end up with two answers. The first one, if you use calculator, the first one will be approximately like something 0.3. And the other one will be approximately negative 0.8. Ah, negative 0.8. Correct? Now, in step 4, I'll draw my number line. And I'll put these 2 points on the number line. Here, negative 0.8. I'll just mark, right? And here, 0.3. Which one goes to the right? Which one goes to the left? That's important, because when I was explaining an example for you, I put the numbers in the wrong places, then I corrected. You should be careful which number goes to the left, which number goes to the right, correct? Draw your boundaries here. These two lines represent the boundaries. Now, pick up a test point, an easy one, correct? An easy test point, because you are dealing with polynomial function. For example, a test point from this region. If this is 0.3, 1 is an easy test point, correct? If this is 0.3, another easiest point is 0. The most easiest point is 0. If 0 is not the solution, correct? I'll pick up 0 and I'll plug it in my inequality, which is what? 4x squared plus 2x minus 1 less than equals 0. 4x squared plus 2x minus 1 less than equals 0, and I'll plug 0 here. Then it will be 4 times 0 squared plus 2 times 0 minus 1 less than equals 0. This part becomes 0, this part becomes 0. Negative 1 less than equals 0. True or false? Of course, it's a true statement. Correct? If it's a true statement, immediately I know where is my solution. If I show on the other number line, I want to do it here again. I want to draw another number line for you. Here was your 0.3. Here my test point 0, and here you had negative 0.8. These were your boundaries. Here you have infinity, here you have negative infinity. If 0 is true, I told you, because I'm dealing with polynomial functions. If this is true, then this one becomes false, this one becomes false, because it's a pattern of true, false, true, false. Believe me, even if you plug in 1 in your inequality, you will see you will end up with a false statement. Now, where is my solution? Your solution is always, always the true part, correct? For negative 0.8, should I use parentheses or bracket? This sign, because you have less than equal, gives you the decision to use bracket or parentheses. Definitely what? Bracket. Then bracket, negative 0.8, comma, 0.3, bracket. That's the solution for your inequality. Let me do another one for you. Example number 2. X squared minus 9 greater than 0. I don't have a step 1 in this example. Everything is on one side, the other side is 0. I'll immediately jump to step 2. Factor and make it equal to 0, factor and solve. If you cannot factor, definitely use the quadratic formula because it's a quadratic polynomial. Correct? X squared minus 9 equal to 0. I can factor it easily as a x plus 3 times x minus 3 because it's the difference of the squares. Now from here, x plus 3 equals 0. It means x equals negative 3. X minus 3 equals 0. It means x equal what? 3. These are my boundary points, correct? I will draw my number line. Here 3. I'll mark here as a negative 3. Draw my boundaries. Here you have positive infinity. Here you have negative infinity. Pick up a test point. The easiest one is what? 0. But remember, where is 0? 0 is between negative 3 and what? And 3, correct? Plug in this number and you are given inequality. Your inequality was x squared minus 9 greater than 0. Plug in 0. It means 0 squared minus 9 greater than 0. This part becomes 0. Is negative 9 is greater than 0? Of course not. It's a false statement, correct? Then, where is my solution? If this one is false, definitely this one is true, this one is true. If you say no, pick up another test point here. 4, pick up another test point here, for example, negative 4. Plug in to your inequality and you will see you will end up with a true statement. Okay, this is the solution, this part, and this part is the solution. Then how to write my final answer? My final answer is parentheses, negative infinity to 3. Should I use parentheses for 3 or bracket? Because the inequality is given as the only greater, right? You don't have equal sign, then you use parentheses for 3. Then the other part is parentheses 3 to infinity. To connect these two solutions, you put the union sign in between. Correct? Let's do one more example. I'll copy this one from your book. Example 3. X cubed plus x squared. Oh, this one even is not quadratic. It's higher degree. Less than equal 4x plus 4. Step 1, move everything to one side. Subtract 4x, subtract 4 from both sides. Then you can write x cubed plus x squared minus 4x minus 4 less than equals 0. I think even this one you can factor. If not, you know now the technique synthetic division, right? You use the synthetic division and you can find the factors, but this one is really easy. You can use the grouping method and you can factor, right? Between x cubed and x squared is common. Then what left inside? X plus 1. Between negative 4x and negative 4 is common. Then what left inside? X plus 1. And make it equal to 0. I did 2 steps and 1. Now, the parentheses that they are the same, take one of them, x plus 1, and put these two in the second parentheses. X squared minus 4 equals 0. Oh, you see, again you can factor x squared minus 4. Then your parentheses will be, your factors will be x plus 1 times, open to new parentheses. What are the factors of x squared minus 4? Of course, x plus 2 and what? X minus 2. Set each parenthesis equals 0. x plus 1 equals 0 and solve. X equals negative 1. X plus 2 equals 0. Solve it. X equals negative 2. X minus 2 equals 0. And if you solve, x equals positive 2. These are your boundary points. Or in other language, x-intercept, right? Draw a number line. Put the points. Here is 2. Then, of course, here negative 1. Here negative 2. Draw the boundaries, please. Pick up a test point, the easiest one, which is what? 0. Plug in your test point in your original inequality, or the one that you sent everything to one side. Which one you use, it doesn't matter. Correct? What was the one that I changed it? This one. You have x cubed plus x squared minus 4x minus 4 less than equals 0. If you plug in 0, this part becomes 0, this part becomes 0, this part becomes 0. Easy, even I don't need to plug, right? We are in college algebra, we know if we plug 0, what's happening, right? The terms that they have x, definitely they become 0, right? Then what I end up with, negative 4 less than equals 0. Is this a true statement or false? Of course, true. Then this part is true. Definitely this one is false. This one is false. This one is what? True. Final answer? My final answer is the true part, right? The true part is my solution. Because I have less than equal to 0, of course, for the points, I will use bracket, right? Then negative infinity, comma, negative 2, bracket, union. The other part is bracket, negative 1, comma, 2, bracket. That's the solution for the given inequality. Correct? I'll stop the lecture, part 1 here, and I'll do another video for you, and I explain how to deal with rational inequalities. This one was polynomial. In next video, I'll explain to you how to deal with rational inequalities.